Hey, we have here today an interesting integral from the UNSW Integration Bee 2022. This was knockout round 1, problem 2. We have the integral of x over 1 minus 5x squared times the square root of 2 over 1 plus 5x squared minus 1 dx. Okay, when I was looking at it at first, it seemed pretty scary because I didn't know what to do with it. I don't really see a good way to start. I don't see a good u substitution here, and I don't know that integration by parts would work, or not easily anyway. And what I thought I could do is just maybe take what's inside the radical here and see if we could just simplify that by getting a common denominator. So let's see what happens when I take this 1. We'll write this as 1 plus 5x squared over 1 plus 5x squared. And then just subtracting this with a common denominator. When I do that, we'll have 2 minus 1 is 1, and then minus 5x squared. And now when I put this back into the integral, what I'll do is split this into two radicals. So I'll write it as x times square root of the numerator 1 minus 5x squared, and then we'll have our 1 minus 5x squared, and then we'll have a square root of 1 plus 5x squared. Now we notice we have 1 minus 5x squared in both these. What I can do is take this one and divide them together, just noticing that this will be like a half power here, and this is a first power. So when I do that and rewrite it, I can have this as a square root of 1 minus 5x squared in the denominator, and we'll still have this. And the numerator will just have our x and a dx here. Then from here, what I want to do is just multiply these two together, get it under one radical. And if I multiply this all the way out, we'd have minus 25x to the fourth. But instead of doing it like that, I'm going to just leave it as a 5x squared. But now at this point, I think I'm in pretty good shape for a u substitution, making this here my u. So we'll say u equals 5x squared. And then our du is going to be just, taking the derivative here is just going to be 10x dx. Well, if I just take the numerator and multiply it by 10, then that's going to be exactly our du. We'll bring a 1/10 out front, so I'm not changing it. And then I'll just make my substitution now. So we're just going to have our du in the numerator, and then this is going to be the square root of 1 minus u squared. But now this is just a really common integral. This is actually just arc sine right here. So if I do this integral, we're just going to end up with arc sine of u, and then all I need to do to finish it off is just back substitute right here. So for our final solution, we're just going to have arc sine 5x squared all over 10 plus c, and that's it. Okay, that's it. Good problem. We'll stop it there. Thanks everyone for watching. Have a great day.